arithmetic progression and a convergent geometric progression each have first term a half, the sum of the second terms is a half, and the sum of the third terms in the progressions is 1/8. Well, let's first of all look at the arithmetic. So first term is a half, second term would be a half plus a common difference, we don't know what that is, and the third term would be a half plus 2 times the common difference. And then the geometric, first term is a half, then it will be a half r, where r is our common ratio, and then a half r squared. We can use this information now. So the sum of the second terms is a half. That means a half plus d plus a half r is going to equal a half. And that means that d is going to equal, well, d plus a half r is going to equal 0, so d is equal to minus a half r. Or, no, let me leave it like that for a moment. And then half plus 2d plus a half r squared is equal to 1/8. Okay, now I'm asked what the sum of to infinity is, so I want to solve for r. Therefore, I'm going to substitute in, actually, for this value of d. It's now minus a half r. So therefore, a half minus r plus a half r squared is equal to 1/8. And I've got myself a quadratic in r. I'm going to times... No, I think I'll subtract the 1/8 first. So a half minus 1/8 is going to be 3/8. All right, so yeah, I'm going to times through by 8 now. So 4r squared minus 8r plus 3 equals 0. Let's try and factorize it. Now we could have 4r and r, or 2r and 2r, but what I do know is that if it's going to factorize, we'll definitely have a 3 and a 1, so that's going to help, and they're both going to have to be negative. And yeah, let's go with 2r. I can see that working, because then I'll get minus 2r minus 6r, all checks out. So then r is going to equal a half, or 3/2. But remember, right at the start, it said that it was a convergent geometric progression. That means it's not going to get bigger and bigger. It's going to approach 0 ultimately. That's when the modulus of r is less than 1. So r is between -1 and 1. So we're going to reject that one there. It must be that r is a half. And therefore the sum to infinity, which is a over 1 minus r, is equal to a half divided by 1 minus a half, which gives me the answer of 1.